Welcome to the first in a series of 3 lectures dealing with mole conversions. This first lecture will be looking at molar mass. You need to make sure that you have your red, white, and blue periodic table. You need a pencil or pen and paper, and you need your calculator. As we go through this video lecture, feel free to pause at any point if you need to write a question about something you don't understand or clarification about something you need to know more on. Hopefully, as we go through the video and we finish the lecture, those questions will be answered. If not, I strongly recommend that you address those questions with your instructor so that as we move on to the next segment, you still don't have those questions in your mind. Okay? All right, so let's get ourselves started. Step 1, in order to find the molar mass, you have to know the formula of the compound that you want to know the molar mass of. Here, we have a familiar compound for you, which is water, H2O. Also, there is a coefficient in front of the H2O. Now, when you were balancing chemical equations, remember you could put the coefficient to change the total number of the elements that you needed to balance on both sides. You could not change the formula of the compound. And so we're just going to review that real quick just to make sure we all remember those things because you're going to need that for this particular unit. Remember that the coefficient tells us the total number of molecules of that particular compound. The symbol tells us which element is in that particular molecule. And remember that the subscript tells us the number of atoms of the symbol of the element with the symbol in front of it. What do I mean by that? Just to make sure we remember, the hydrogen and the subscript 2 go together. That tells us that for every molecule of water, there are 2 hydrogens and there's 1 oxygen. We don't see the number of subscript 1 for oxygen because remember we said that 1 is inferred. We don't need to write it. If the element is there, that takes care of the 1, just like we did for balancing equations. Okay? All right, so this is carbon tetrachloride. Notice there is no coefficient in front of carbon tetrachloride, so we can automatically know that there's 1 molecule of carbon tetrachloride because it's there and it exists. In the molecule of carbon tetrachloride, looking at subscripts, we find that there is only 1 carbon and there are 4 chlorines atoms. Make sure you understand that. Go ahead and pause the video at any time. This is magnesium chloride. There is a 3 in front of it, coefficient, that tells us that that 3 now is 3 molecules of magnesium chloride. Each magnesium chloride has 1 magnesium, but since there are 3 molecules, there's a total of 3 magnesiums. And each magnesium chloride has 2 chlorines, but there's a total of 3 magnesium chlorides, so there's a total of 6 chlorines. Now, for those of us who are a little more visual, basically what we're saying is you have 1, 2, 3 magnesium chlorides. Just like in math, instead of saying x plus x plus x, we write 3x. Instead of saying magnesium chloride plus magnesium chloride plus magnesium chloride, we just say 3 magnesium chlorides. Okay? And if you look at the total numbers, you'll notice that there are 3 magnesiums in these 3 magnesium chlorides total. And if we look at the chlorines, we see that there's a total of 6 chlorines in these 3 magnesium chlorides. So the number that you see here matches the number of magnesium chlorides, and the number you see here matches the number of chlorines. Again, pause the video if you need to, ask the question, and of course feel free to rewind the video at any time and go back through it. So for practice, this is sodium oxide. How many molecules of sodium oxide are there? How many total atoms of sodium are there? How many total atoms of oxygen are there? Pause the video and press play when you're ready to check yourself. That 5 coefficient tells us there are 5 molecules of sodium oxide. The subscript 2 tells us each molecule has 2 atoms of sodium, and 2 times 5 gives us a total of 10 atoms. And oxygen has no subscript, so that tells us there's 1 atom of oxygen, and since there are 5 molecules, that's a total of 5 oxygens. If you got that correct, you're doing just fine. If not, make sure you write down where you think you went wrong, what you need clarification on, and hopefully we'll answer this or you can address it with your instructor. Magnesium sulfide. How many molecules total? How many magnesium atoms total? How many sulfur atoms total? Pause the video and press play when you are ready to continue and check yourself. There is 1 molecule of magnesium sulfide because, again, there's no coefficient in front of that. Each magnesium sulfide has 1 atom of magnesium and has 1 atom of sulfur. Pause it if you need to write clarifying questions. If you got that correct, excellent. So now that we know how the pieces of a formula that we need to know, let's talk about molar mass. Molar mass is the number of grams of each element in a molecule of the compound, and then you add them all together, and that gives you molar mass. Now, I want to point one thing out that you're going to need to pay attention to. This is 1 molecule of the compound. That is what gives you the molar mass. You're going to add up the mass of the elements in 1 molecule to get the molar mass. So somewhere in your notes, put a star that the molar mass is the grams of each element in 1 molecule of the compound. Why am I emphasizing that? I'll show you as we go on. What is molar mass? The units of molar mass. Well, we know it's mass, right? So we know grams are somewhere in there. But there's a gentleman by the name of Avogadro. And what Avogadro said is that he can sum up a mole. Kind of like, we know that if I say a dozen, you know I'm talking about 12. If I say a dozen chairs, you know I'm talking about 12. If I say a dozen feathers, you know I'm talking about 12. However, does the mass of a dozen chairs equal to the mass of a dozen feathers? The answer, of course, is no. But does that keep them from being a dozen of each? No. So what Avogadro did was he looked at the masses of the elements of the periodic table. And by his calculations, he calculated that a mole is 6.02 times 10 to the 23. Or 6.02 e to the 23, which is what we use in speaking chemistry. And that is called a mole. So according to Avogadro, I can talk about a mole of atoms, a mole of ions, a mole of molecules. If I'm talking about chemistry, I could talk about a mole of trucks, a mole of rocks, a mole of people. Either way, I'm talking about 6.02 e to the 23 of those things. That's Avogadro's number. He says that if I take 6.02 E23 molecules of H2O water and I put them on a scale that doesn't calculate weight but mass, that is going to come out to 18 grams. If I take 6.02 E23 of the cobalt, remember we did the cobalt? If I take 6.02 E23 atoms of cobalt and put them on a scale, I am going to get a mass that will round to 59 grams for that mole. If I take a hydrogen atom and I do 6.02 E23 hydrogen atoms and I put them on a scale, the mass of those hydrogen atoms will round out to 1 gram. So if you look at the elements on your periodic table, in that upper right where you see the atomic mass that your periodic table is showing you is 6.02 e to the 23 atoms of that element, what the mass of that element is going to be. So write that down somewhere. The atomic mass on your periodic table is equal to 6.02 e to the 23 atoms of that particular element. Again, the mass on your periodic table is equal to 6.02 E23 atoms of that particular element. So when I'm talking about molar mass, then I'm actually going to be talking about the number of grams. Oops, let me write this a little better. There we go, so you can see the number of grams in a mole of that compound, that molecule, that ion, that atom. So the units for molar mass then is going to be grams per mole. Now we are very much a stickler when it comes to writing the correct units. So put a star around it or something and know that when you are talking about the molar mass, we insist that you put the units grams per mole. Doesn't matter that you have the right number. You've got to have the correct unit, which is grams per mole. And remember we were talking earlier, this has to be based on one molecule. Has to be based on one molecule. Now, if I have more than one molecule, it's not grams per mole. It's just the mass, which is grams. But if I'm talking about one molecule of this compound, or one molecule of whatever, I am talking about grams per mole as my unit. Okay? So, best way we can do it, practice is what makes perfect in my world. Okay. So we now know that the number of grams of a substance that fits in a mole is called its molar mass. So find hydrogen on your periodic table. Notice that its atomic mass rounds to 1 gram. That is the mass of that hydrogen atom. That one hydrogen atom then is 1 gram per mole. If I look at the diatomic molecule of hydrogen, since there are 2 hydrogens, then that's going to be equal to 2 grams per 1 mole of that molecule of hydrogen. If I look at the atom of oxygen and I look on the periodic table, find oxygen, look at the atomic mass, it should round to 16 grams. That means that 1 oxygen atom is 16 grams per mole. And if I look at water, which we just looked at, remember I told you to take 6.02 E23 or a mole of water and I put it in on a scale, then it's going to mass out to 18 grams. Well, if you look at H and O, H has 1 gram, O has 16. Well, the formula for water is H2O. So 2 hydrogens at 1 gram and 1 oxygen at 16 grams is going to give you a total of 18 grams to 1 mole of H2O. Pause the video if you need to. Make sure you understand this. Write any clarifying or reflective questions you have or questions you have, and hopefully we'll answer them by the end of this lecture. So let's go back to carbon tetrachloride. On your periodic table, carbon has a mass of 12 grams per mole. Find carbon, that's atomic number 6. And now find chlorine, which is atomic number 17. Chlorine has a mass of 35.5 grams per mole. And there are 4 chlorines. So if you take that number and multiply it by 4, you get 142 grams per mole. Well, let's pause and stop. Why? Because I told you that you have to round those. Well, there is an exception to every rule because there's always an exception to every rule. The exception to every rule is chlorine. We have found that the chlorine molecule, which is Cl2, is equal to a perfect 71 grams per mole. A perfect 71 grams per mole. So, the IUPAC, scientific, chemistry, community, call them what you will, made the decision that chlorine is the only exception to the rule that you cannot round. It is the only one you cannot round. Let me put a little, make this in red so we can understand this a little better. Chlorine, you cannot round to a whole number. You can only round it to 35.5 grams per mole. So look at chlorine on your periodic table. Notice it is 35.45 grams per mole. You can round it to 35.5 grams per mole, but you cannot round that to 36. Anything else on the periodic table, you can round. Feel free to round. But when it comes to the chlorine, you cannot round chlorine. It has to be 35.5 grams per mole. Put a note somewhere, make a note somewhere. Okay? So, based on that, then, if we go back to what we were looking at, chlorine then is going to be 142 grams per mole. So, we said molar masses, when you take the individual masses of the elements that make up the molecule and you add them all together, that is going to give you the molar mass of one molecule. We have only one molecule of carbon tetrachloride, so using your calculator, clear your calculator, put 12 plus 142, and that is going to give us the total mass of one molecule, which is 154 grams per mole. Again, grams per mole, because that is equal to one molecule. Pause the video if you need to. Make sure that you understand that. If not, go ahead and write your question down and then press play when you're ready to continue. Well, what if I had 3 moles of carbon tetrachloride? Well, if I know 1 mole of carbon tetrachloride is 154 grams per 1 mole, and I have 3 moles of carbon tetrachloride, well, I know that the total of 3 moles of carbon tetrachloride is going to be equal to 462 grams. I think they might have forgot to put the little gram there. Is that grams per mole? Absolutely not. Why? Because molar mass is the mass of the elements in one molecule. We are talking about 3 molecules or 3 moles. 3 moles is equal to that many grams. Okay? So just remember that if I'm talking about 1 molecule, it's grams per mole. If I'm talking about more than 1 molecule, it's just grams. All right, let's keep going. And again, practice makes perfect. So here we have 1 mole of ammonia is equal to 17 grams. Should be per mole. But because I have it written as 1 mole of NH3, that 1 mole is 17 grams. Because the molar mass of nitrogen is 14 grams per mole, the molar mass of hydrogen is 1 gram per mole, and there are 3 hydrogens. 1 mole of yttrium hydroxide is 140 grams because yttrium has a molar mass of 89. Hydroxide, there are 3 of them. Each oxygen has a molar mass of 16 grams per mole. Each hydrogen has a molar mass of 1 gram per mole, and there are 3 of those, okay? Or I could say yttrium is 89, and each hydroxide is 16 grams per mole, hydroxide, OH, and there are 3. So however you want to swing that. 2 moles of lead 2 chloride is equal to 2 times 273 grams, which is 556 grams. Why? Because lead is 204 and there's only 1, and I have 2 chlorines. Again, 35.5, which is going to be a total of 71. So 207 plus 71 is going to give me a total of 278 grams times 2. Okay? Because there are 2 moles. So, your turn. We have 1 mole of calcium oxide. Calculate the molar mass. Pause the video to do that, and then press play when you're ready to continue. Check yourself. Did you get 72 grams in 1 mole? If so, you're doing just fine. Look at 1 mole of barium silicate. There you go. Calculate the molar mass. You have 1 barium, you have 1 silicon, you have 3 oxygens. Pause the video and press play when you're ready. Check yourself. Did you get 213 grams? Good. And you have 2 moles of osmium 4 iodate, which I'm sure you know that by now, it's iodate. Calculate the molar mass. Did you get 1,780 grams? If so, you're correct. Now, the question comes to mind, well, Dr. Hudson, you said that the molar mass is in grams per mole. So why is it that we're just writing grams? Well, that's easy enough because I'm telling you there's 1 mole. And what is the mass? Okay? I'm telling you. Now, if I was just going to write CaO2, that is equal to 72 grams per mole. Okay, but I'm telling you there's 1 mole, and you're giving me grams. I just want to make sure we clarify that, okay? When it comes to 2 moles of osmium iodate, am I going to write grams per mole? No, I would put 2 OSiO3 4 is equal to 1,780 grams. All right, I hope you got that understanding. If not, make sure you write that down. Okay, now, multiple molar masses, which we pretty much did. Add the total mass of the atoms in 1 molecule times the total number of molecules. That's pretty much what we did. So 3 magnesium chloride, of course, is the magnesium mass is 24 grams per mole because there's 3 times 1. And we know that magnesium is 24. And then you have 35.5 grams per mole for chlorine, which is 2, which is 71. You take the whole thing, multiply it by 3, and that is going to give you the total mass of 1 molecule being 95 grams per mole. So 3 magnesium, 6 chlorines, right? Or you could just say the magnesium and the chlorine in 1 molecule gives you your total, and then multiply it by 3. So whichever way is easier for you. Okay? So either way, you calculate the mass of the molecule, and then you multiply it by 3. Or, again, you could take magnesium, take 24 times 3. You could take chlorine, take 35.5 times 6. And that would give you 285 grams total. What about sodium oxide? What is the total molar mass of sodium oxide? However you want to do it, you can either calculate the mass of sodium and oxide in 1 molecule and multiply it by 5, or you can multiply the total number of sodiums times the total number of oxygens. Pause the video, come back and check. You should have got a total mass of 318 grams. Is that at 318 grams per mole? Absolutely not. Absolutely not, because I'm talking about more than one. So this is not grams per mole. It's just grams. Okay? Magnesium sulfide, would be a total mass of 56 grams per mole because there's only one molecule. And I'm just doing this because I want to make sure we got that. There's only one molecule of magnesium sulfide. Okay? Please make sure you understand that. Please make sure you understand that. Okay? All right, so here's a little practice worksheet, and we are going to do just a few of these together. Certainly you can do them on your own, but I'm going to do some for you, and then I want you to pause the video and just kind of practice on your own. Let's look at the ones that are a little bit more, how I'm going to say, challenging. All right, we're going to do number 5 together, and we're going to do number 9 together, and we'll do number 2 together. That's enough. We'll do 2 of those. Okay, first of all, you guys should know the name. That should be a problem. But if you look at the first one, this is lead, and the ion you should know is sulfate. Well, lead is a transition metal with more than one form. So how could I figure out which lead that is? Well, I know I have one lead. Let me erase that a little bit better. I have one Pb plus I have one sulfate ion. And I know sulfate ion has a -2 charge, is equal to a total charge of 0. Well, how do we do that? Well, I do know the sulfate ion is a -2 charge. So I'm going to go ahead and put a -2 in here. And now I have an algebraic expression. I need to solve for Pb. Well, that's going to be Pb minus 2 is equal to 0. And that means Pb is going to be equal to a positive 2 because we're talking about charges. We leave that. And if Pb is a charge of 2, then now I know that I'm dealing with lead 2 because it has to have a Roman numeral. And this is sulfate. Okay? All right, so what is the molar mass then of lead 2 sulfate? I have 1 lead, I have 1 sulfur, and I have 4 oxygens. So use your periodic table. Find the molar mass for lead. Lead has a molar mass that rounds to 207. Find the molar mass of sulfur. Sulfur has a molar mass that rounds to 32. And there is 1 sulfur. And then I guess I should put this so that's a little neater. There we go, 32. And then I have oxygen. Oxygen's molar mass rounds to 16. But remember, there are 4 of them. So you need to add all those together. So clear your calculator. Put in 207 plus 32 plus open parentheses 4 times 16 close parentheses, because you got to tell your calculator that's one thing. Press the equal sign and you should get 303. Since there's only one molecule, then it's 303 grams per mole. Now if you don't have room to write MOLE, believe it or not, the shortcut is MOL. Okay? All right, let's look at the next one. What is the name of this? Well, NH4 from your orange and blue periodic table tells you that this NH4 is called ammonium. And the CO3, you should know, is called carbonate. This is then going to be called ammonium carbonate. Okay? And when we look at the ammonium carbonate, we find that we have a total of 2 NH4s, 1 carbon, and O3. You can take it as a group of NH4 or you can do each one individually. If you do them individually, you have 2 nitrogens because NH4 twice is 2 nitrogens. The molar mass of nitrogen is 14. So you have 2 times 14. And I'm going to put parentheses just so we can remind ourselves when we add them together. For hydrogen, the molar mass is rounds to 1. And there's a total of 8 hydrogens. So that's 8 times 1. The carbon has a molar mass that rounds to 12. So that's 12. And the oxygen has a molar mass that rounds to 16, but there are 3. So that is 3 times 16. All right, clear your calculator. Open parentheses, because you're going to tell your calculator that's one thing, that nitrogen. 2 times 14, so that's one thing, plus, open your calculator, and you could put 8, or 8 times 1 for kicks and giggles, so I'm just writing them all so I can get into the habit of it. 8 times 1, close parentheses, because that's another one thing, plus, there's 1 carbon, so that's 12, 1, 2, plus, I have 3 oxygen, so that's open parentheses, 3 times 1, 6, close parentheses, press the equal sign, and I get 96, and it's only one molecule, so that is grams per mole. Okay? All right, you ready for the big one? All right, this one is zinc, and you don't know it, but I believe that's acetate. So when we look at all the components, we have 1 zinc, and we have C2H3O2 twice. So let's find our periodic table. Find zinc. Zinc rounds to, what is that, 65. So we have 65. We have a total of 4 carbons, and the atomic mass of carbon is 12. It rounds to 12. So we have 4 times 12, and again, we're going to put those in parentheses. We have 2 times 3 is 6 hydrogens, and the atomic mass of hydrogen is 1. So 6 times 1 will take care of our hydrogen. And we have 2 times 2, which is 4 oxygens. The atomic mass of oxygen is 16, rounds to 16. So that's going to be 4 times 16. Okay, clear your calculator. Open parentheses. Well, actually, let's do the 65 first. 65 plus, open parentheses, 4 times 12, close parentheses, plus, open parentheses, 6 times 1, close parentheses, plus, open parentheses, 4 times 16, close parentheses, push the equal sign, and we get 183 grams per mole. But let's not forget the name of this. This is zinc, and zinc is a transition metal but only has one form, and I believe this is called acetate. Okay? And if it's not called acetate, well, just put that on Dr. Hudson. It's Dr. Hudson's fault. But do you see the way we did these? So what I want you to do is, on your own, practice doing some of them, or go back just over the 3 that I've done to make sure you know how they're done. I'm going to remove this so you can't see. And it's okay that you can see the answers to the question. Just make sure that your calculations come up to those 3 answers. If it does, you're doing just fine. If it doesn't, then write that question down, and I think we've got like maybe 1 or more of these, and hopefully we'll answer it that way, or your instructor can answer that question for you. Okay? Or do any one of these and just send an email to your instructor, ask him, did I get this right? Okay? All right. Let's move on. All right, this time they're giving us the name. We have to give the formula, and we have to give the molar mass. Now, why am I doing this? Because you also need to continue to practice naming. I cannot impress upon you, now that we're in quarter 2, you've got to know the names of these compounds. It's not going to go away. You're going to find them on every major assessment and summative. That means your unit tests and your quarter exams. They're always going to be there. So you don't want to keep running into the same wall. I don't know how to do this. And the only way to get this done is practice. Practice makes perfect. So you have all the resources that we've given you in chemistry. Please make sure you take advantage of practicing the worksheets, going through the videos, going through the gap fill exercises, or whatever the resources are that we have available for you. You have to know these. You have to know the formula for this, for everything, and you have to know your orange and blue polyatomic ions. You have to know those. You can ask anyone who took chemistry. The biggest part is ask them, do they always give you formulas and naming? And they will tell you yes. Okay, so let's do a couple of these. We're going to do a few, but a few is good enough. All right, let's do hydrogen phosphite. That's a good one. Number 9. Let's do calcium carbonate. That's a good one. And for the third, we'll do iron 3 sulfate. That's a good one too. Okay, the first one they did for you, which is hydrogen nitrate. And we've given you the name because we probably haven't gone over acids with you yet. If not, we will. Trust me. So hydrogen nitrate, given that we take the hydrogen, which is our cation, and write its symbol first, and then the nitrate, which is our anion, and write its symbol second. I'm going to change the color of this so it doesn't match what we did there. So hydrogen, which is here, and let me get another color for that. Nitrate, which is here. Again, it is one of your orange and blue polyatomic ions. You gotta know those. You gotta know those. Did I say you gotta know those? Yeah, you gotta know those. Okay? All right, so let's look at what we have. Calcium carbonate. Well, we know that calcium, you should know, calcium is in column 2. So calcium is not a transition metal. So Ca has a positive 2 charge. Carbonate is on your polyatomic ion sheet, which is CO3. It has a negative 2 charge. Drop the sign, drop it down, switch and simplify. And your formula should be CaCO3. So now we have the formula. So now I want you to pause the video and go ahead and calculate the molar mass. And then come back and check and see if you got it right. All right? So when we look at calcium, on the periodic table, calcium has a molar mass. God, I hope I can see this because this is really small for me. 40. And there's only one calcium, so that's going to be 40. Carbonate, there's only one carbon, so that has a mass of 12. Okay, and then oxygen, there are 3 oxygens. So that is going to be 3 times the molar mass of oxygen is 16 grams per mole. All right, and we put that in parentheses so we know that what we put on that paper is exactly what we're going to put on our calculators, okay? So 40, clear your calculator if it's got anything on there. Okay, I'll start again. 40 plus 12 plus open parentheses, 3 times 1, 6, close parentheses, press the equal sign, and you should get 100. And that's 100 grams. There's only one mole of that, molecule of that, so that is a gram per mole. Because remember, the molar mass is for one molecule. All right? Okay, let's look at the next one. Iron 3 sulfate. Well, we know what the charge of the iron is because it says it's iron 3. So that tells us automatically that it's going to be Fe plus 3. And this is sulfate. What is the formula for sulfate? You should know that. Why don't you pause the video, see if you get it right, and then replay it, see if you got it correct. Sulfate is SO4, and it has a negative 2 charge. Okay, so when we drop the sign, drop it down, switch and simplify, we come up with Fe2, and in parentheses, because there's going to be 3 of them, SO4, 3. Okay, so now we have the formula. So pause the video once again and see if you can calculate what the molar mass is going to be. Play the video when you're done to make sure that you have it correct. All right, so when I look up iron, it has a molar mass that rounds to, is that a 56? Yep, so that's 56. And there are two of them, so that's 2 times 56. And I'm going to put that in parentheses, so I know what to put in my calculator. And then there are 3 sulfurs in the sulfate ion, because there are 3 sulfate ions. And I know that sulfur has a molar mass of 32, so that's going to be 3 times 32. And then there are 3 times 4, which is 12 oxygens. And I know oxygen has a molar mass of 16 grams per mole. So that's going to be 12 times 16. So it's going to be a fairly large number. Clear your calculator. Open parentheses. 2 times 56, close parentheses, plus, open parentheses, 3 times 32, close parentheses, plus, open parentheses, 12 times 16, close parentheses, double check and make sure you have that all right, equals, that is going to be equal to 400 grams per mole. If I got that wrong, tell your instructor I got it wrong, but I believe we're on the right track there. Okay? All right, and finally, let's do the last one. This is phosphorus acid, which is actually hydrogen phosphite. Pause the video, see if you can get that correct, and then play to check and see if you've wrote the correct formula for that. Okay? All right, so hydrogen, I know hydrogen has a positive 1 charge. Phosphite is PO3 with a negative 3 charge. Drop the sign, drop it down, switch and simplify, and the formula is H3PO3. So why don't I put the H in parentheses? Because it's not a polyatomic ion. It doesn't need to be in parentheses. All polyatomic ions need to be in parentheses if there's more than one. Okay, now we have to find the molar mass. Once again, pause the video. See if you can figure out the molar mass and then come back and check and see if you have it correct. So there are 3 hydrogens. So I have, open parentheses, 3 times the molar mass of hydrogen, which is 1 gram per mole. I have 1 phosphorus, and the molar mass of phosphorus rounds to 31. And I have 3 oxygens. So that's going to be, in parentheses, 3 times the molar mass of oxygen, which is 16 grams per mole. And then I'm going to clear my calculator. Open parentheses, 3 times 1, close parentheses, plus 31, plus, open parentheses, 3 times 16, close parentheses, equals, and you should get an 82 grams per mole. Okay? Once again, feel free to, let me move this out the way so you can't see how I did it. Feel free to go over those 3. You don't need new ones. You just need to know how to do it, right? So feel free to go back over those 3, given those answers, or rewind the video, so you can follow along with writing the formulas and writing the answers and writing the names from the formulas. That would be good for you too, wherever it is that you're having your most difficulty. And make sure that you're answering that correctly. Make sure that you have the process correct. Make sure you ask questions to your instructor. If you still can't get it, ask your instructor if there's resources available, which there are, I know, because we helped to develop them together. But go through those, and if you're still having difficulty, just all I can tell y'all is practice, especially from this unit on. For this quarter, and you're going to be going into quarters 3 and 4, the best way you can do and solve these and do well on these is if you continue to practice, 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 practice is what makes perfect. Okay? All right. This, I believe, ends this particular unit. I'll see you on the second segment. Have a great day.